Hey guys, so I'm going to walk you through some of the questions in our first review packet that we got. So looking at question 1, it says, based on the construction below, which statement must be true? So let's look at the picture. Angle ABC, and we're cutting that in half. This is your angle bisector. So if it's a little confusing with just letters, give some numbers to it. So if we're talking about angle ABC, we're just going to call that entire angle 60 degrees. So if we took an angle bisector, we cut that total of 60 into two congruent 30-degree angles. So now we could go through our choices. So angle ABD, so ABD we said is 30. Is that equal to half of angle CBD? CBD is 30. Is 30 equal to 15? No, so it can't be choice 1. Now we're going to go through choice 2. The measure of angle ABD, which is 30, is that equal to the measure of angle CBD, which is 30? Yes, so we're done and we can move on. Okay, question 2. It says, in the diagram below, line P is parallel to line S, and we want to figure out what X is. So let's look up top. We know if intersecting lines occur, we have congruent vertical angles. So 74, which is right here, has a vertical angle of 74. Our 43 is also right here. And from here we could go a few different ways. So we know P and S are considered parallel. So that means that angle of 43 is going to occur right here as well because they're alternate interior angles, which means they are congruent. So if we focus in on our triangle right here, we should know that angles within a triangle sum to 180. So we could do 74 plus 43 plus x equals 180. 74 and 43, when you add them together, is 117 plus x equals 180 minus 117, and x is equal to 63. Another way in which you could do that is focus in on this piece right here. We know that angles on a line sum to 180. So 74 plus 43, again, is 117. 180 minus 117 is 63. So if we said this piece is 63, 63 and x are alternate interior angles, which means they are congruent. Okay, so now let's look at question 3. Question 3 says, given triangle ABC with the measure of angle B at 56 and side AC extended to D as shown below, which value of x makes AB congruent to CB? So we know this angle on the outside is an exterior angle. If we get that measure, we know it should be equal to the 56 plus whatever A is. So first, let's try to figure out our inside angles. We want AB to be congruent to BC, which means it's an isosceles triangle. Therefore, our base angles, which I'm just going to call Y, would be equal. Then we have this triangle, and we know that angles in a triangle add up to 180. So 56 plus y equals 180. So from here, we're going to combine like terms on the left-hand side. 56 plus 2y equals 180. I'm going to subtract my 56, and we have 2y equals 124. Divide by 2, and y is equal to 62. So now that we have our values for y, I'm just going to go back and plug them in. So 62 and 62. But again, it says which value of x. So x, that outside angle, that exterior angle, is equal to the sum of the two non-adjacent angles. So x equals 56 plus 62. So x is equal to 118, which is choice 3. In question 4, we're still applying what we did in the previous problem with our exterior angle. So let's mark up our picture. We have the measure of BCD, which is right here, is 6x plus 2. Then they told us the measure of BAC, which is this angle right here, is 3x plus 15. And the measure of angle ABC, which is this measure, that angle right there, is 2x minus 1. So we should notice that we have an exterior angle and the two non-adjacent angles. So we want to figure out what is the measure of angle ABC. We need to first figure out the value of x. So we're going to take 2x minus 1 and add it with the 3x plus 15 because these two are our non-adjacent angles to our exterior. And we know that the sum of those two should equal that exterior angle of 6x plus 2. On the left-hand side, we're going to combine our like terms. 3 and 2 is 5x. Negative 1 and a positive 15 is a plus 14, which is equal to 6x plus 2. Now I want to isolate my variable. I'm going to bring over my 5x. And we have 14 is equal to x plus 2. Now I'm going to subtract 2. And x is equal to 12. But again, we don't want to know what the value of x is. We just needed that to substitute back in. We want to figure out what is the measure of angle ABC. So ABC we had as 2x minus 1. We're going to take our value of x that we got and substitute it back in. So 2 times 12 minus 1, 24 minus 1. The measure of angle ABC is equal to 23. Question 5 says the image of triangle DEF is triangle D prime, E prime, F prime. Under which transformation will the triangles not be congruent? So let's look at our keywords in each of our multiple choices. So a reflection, a dilation, and a dilation. We should know that in order for it to be congruent, we have the three rigid motions, which is a reflection, a rotation, and a translation. Under any of those three transformations, we are going to have a congruent figure. So choice 1 and choice 2 are not correct because we want it to be not congruent. So that brings us to our dilation. Under a dilation, we have to look at our scale factor next. So a scale factor of 1 and a scale factor of 3 over 2. So in choice 3, with a dilation and a scale factor of 1, we really aren't doing anything to our image. We're multiplying each coordinate by 1, which means our image did not change. However, choice 4 is the correct answer because we have a scale factor of 3 over 2, which means we're making each side 1.5 times bigger.